All right, let's get started. So today, guys, this is your last two exercises, 9F.2 and 9F.3. And you'll find they just really follow on from 9F. We're just applying those confidence interval skills. So let's get straight into it. In 9F.1, we were doing confidence intervals for proportions. So in the example, we had 100 students and 55 of them playing Fortnite, and we constructed the confidence interval around that. What we're going to do now is just like we did in D.2, where we want to calculate a sample size for a given width, we're going to do that for a proportion. So I'll just explain our formula here. This is for a 95% confidence interval. This is how many people you need to sample to guarantee a certain width of the confidence interval. Now P star is what we use to approximate P hat, because if you think P hat is generally based off of a sample size, and so P star is going to be a value that we use to approximate P hat. So if you look at the notes, we're saying P hat equals P star. Now, if we're not given a value of P hat or P star, then we use the worst case scenario, which is when P equals 0.5. That's going to create the largest width. Okay, but in most circumstances, you will have a preliminary value of P hat. Okay, so continuing from the above example, so we're maintaining the example of students at Tennyson Woods College. How many do we need to sample to have a 95 confidence interval with a width of less than 5%? So let's answer this in two ways. Let's talk about using the value of P hat that we obtained in the first part. So in 9F.1, we have a value of P hat of 0.55. Okay, so if we're going to calculate the number of samples we need, we're going to use this formula here. So we're going to have n is 2 times 1.96, that's for 95% confidence. The width is 5%, we express that as a decimal, that's squared. And then here, this is our value of P star, right? So P star is the preliminary estimate. We've already done an estimate, and that value is 0.55, and then times the inverse event. That's all that we are evaluating. So I'll type that in. And I've got 1521. But remember, 1521.2, remember, whenever you're calculating n, like we did in E.2, and we're doing in F.2, you always round it up. 1522 students, that's how many people we need to sample. Okay, so that was based off of the p-value that we have in part A. However, in some circumstances, you won't know what the proportion is initially. And when that's the case, okay, if you're not given an initial value of P hat, instead you'll use 0.5 to be P star. And that sort of calculates n in the worst case scenario. Okay, very good. So that's F.2. Let's turn the page and we'll talk about F.3. And really what we've got here in F.3 is we've got an old exam question that brings together all of the skills we've talked about in F and provides us with sort of a good example of a stats question in an exam. Now, in an exam, and we'll draw this out more as we approach exam revision, stats questions always provide you with so many words, okay? And part of that is comprehension. It's like you have to read it and extract from that the parts that are necessary for you to solve the mathematics. So they're always going to use more words than are necessary so that you can filter through it. So let's have a read. In the 2004 Australian federal election, 47.4% of voters in South Australia voted for the Liberal Party. A survey conducted in 2006 to assess whether or not support had changed since the 2004 election. A random sample of 80 South Australian voters are asked whether or not they would vote for the Liberal Party in a federal election was held today. 33 out of 80 said they would vote for the Liberal Party if a federal election was held today. Using the sample data, so this is part A, calculate an approximate 95% confidence interval for the proportion of all South Australian voters who would vote for the Liberal Party if a federal election were held today. Okay, so we're constructing a confidence interval. So we'll just go straight to our calculator for that. So just to refresh you on how to do that, menu, stats, we're doing interval Z, first proportion. Our confidence level is going to be 95. Okay, then we have X and we have N. So the question is, what are we putting in here? So we have a survey of 80 people and 33 of them said that they would vote for the Liberal Party if an election was held today. So we're going 33 out of 80. Okay, evaluate that confidence interval, and this is what we get. 3046. Okay, 6 rounds up. And 3 stays as is. Okay, so what this confidence interval shows us is we're 95% confident that if we were to hold the election today being 2006, that the true proportion would lie somewhere in this region. Okay, part B says, would it be reasonable to claim this survey reveals that support for the Liberal Party in South Australia has fallen since the federal election in 2004? Explain your answer. So in 2004, we had 47.4% of voters. That is 0.474. Now this result lies within the confidence interval. Okay, so because this result lies within the confidence interval, there is not sufficient evidence that supports the claim. The claim is not supported that support for the Liberal Party has fallen. So let's explain the answer. Now, whenever you're explaining the answer, they always make a claim, and your comment is always about the claim. It's not is the claim true or false, but does the evidence support the claim? So, would it be reasonable to claim this? No, it would not be reasonable to claim to make the claim rather than restating it. No, it would not be reasonable to make the claim because, okay, so we've answered the question and then we're providing a justification. Okay, always answer the question and always provide a justification. It would not be reasonable to make the claim because the 2004 proportion lies within the confidence interval. Okay, so the proportion from the population proportion from 2004 still lies within the confidence interval that we generated today. All right, part C. So what have we done so far? We've constructed a confidence interval. We've assessed a claim. That's what you're doing in 9F.3 is assessing claims. Now remember, just to draw that out, it's never about the claim is true or the claim is false. It's always about does the evidence support the claim? Does the confidence interval support the claim? In this circumstance, the confidence interval does not support the claim because the result lies within the confidence interval. Okay, how large a sample size is required to produce a data set that would result in a confidence interval with a width no greater than 0.02? So again, we're using our formula from just before. We have n equals 2 times 1.96 for 95 on w squared p star, 1 take p star. Okay, so we've got 2 times 1.96. Now the width they're asking for, 0.02 squared. And here we will use the observed value of P from the current survey, which was 33 out of 80, and then 1 take, so the inverse of that event. Let's evaluate that and then round it up. And 9,309.8, which is 9,310 people that we need to sample. Okay, so yeah, let's leap into 9F2 and 9F3. That's where we're dedicating our efforts. And then come Tuesday,